Chapter 3, Section 3. In this section, we're going to learn properties of functions. Okay, there are 7 objectives. Please read through it. And first, let's look at how to determine even and odd functions from a graph. So in order to determine whether the graph is an even functions graph or odd functions graph, we have to understand what is an even function, what is odd function first, right? So now let's look at the definition. A function f is even if for every number x in its domain, the number negative x is also in the domain, and f of negative x equals f of x. So what it means? That means if replace x by its negative, and then f of x is still the same. Okay, so when replace x by its negative x, the y or the function, the value stay the same. Okay, function doesn't change. Right, so that's why is f of negative x is the same as f of x. So what kind of function, can do that? So think about, okay, just trying to give you a simple example. If function have a one variable x, and then the variable x raised to the even exponents, like x squared, or x fourths, or x6, or x8 power, and so on. Okay, so when you replace by negative x, right, and then negative sign raised to the even exponents, the negative sign eliminated, right? Same as for the fourth power, okay, and all the even exponents. So that's why, replace x by its negative x, the function still remain the same value, okay? And an odd function. What is the odd function definition? A function f is odd if for every number x in its domain, the number negative x is also in the domain, and f of negative x equals negative of f of x. Okay, so this time when we replace x by its negative, and then the function, okay, also become the negative of original. Okay, function value like multiplied by -1. So what kind of function, exact, if I give you a simple example, like variable x raised to the odd exponents, like to the third power, fifth power, seventh power, and so on, right? And then when replace x by negative x, and then -1 raised to the odd exponents, and then that equals negative of x to the third power, right? Negative sign coming outside instead of eliminated. Okay, so that's a typical example for the odd function. Okay, but how to determine whether function or even odd, you have to plug in this definition. Is not simple as that, because function doesn't only have this one term, right? May have multiple terms. And then there's a theorem, okay, tell us the property about even and odd functions graph. If function is even, okay, if and only if the graph symmetric with respect to y-axis. So if and only if that tells us both direction, the statement is true, right? That means function is even, then the graph must be symmetric with respect to the y-axis. And at the same time, if a graph is symmetric with respect to the y-axis, that means, the function must be even. And similarly, a function is odd if and only if graph symmetric with respect to the origin. So that indicates a function is odd, and then its graph must be symmetric with respect to the origin, and vice versa. If the graph symmetric with respect to the origin, and then the function must be odd. Okay. All right, now let's look at an example. We have 3 graphs here. Okay, we need to use that theorem to determine the function is even function or odd function. Okay, if not even nor odd, we say it's neither. So let's look at A. The A is very clear, show, right? This half of the graph do mirror image about the y-axis, right? We got the other half, right? So that's why the graph symmetric with respect to the y-axis, so function must be even, right? And then let's look at the b. Is this graph symmetric with respect to y? No, right? If respect to the y, if this is a half, respect to the y is supposed to look like that, right? Is that correct? If it's a even function, right? Obviously, this is not even. Okay, let's see. Is that odd function? If, let me eliminate this thing. I'm sorry. Okay, if it's an odd, and then if this is a half of the graph, the other half should look like what? This point will be symmetric with respect to the origin, and then this one goes through here, right? And then this one should go through here, so it should look like that, right? It's different than this. So this is not even function, it's not an odd function. So that's belong to neither. Okay, this is an even function. How about this? This is symmetric with respect to the origin, right? You connect the 2 points, must going through the origin and then same distance, right? Here, you see. Connect these 2 points, must go through origin and then same distance. And the same for here. If you pick up any arbitrary point on the graph, you must see those symmetrical point with respect to the origin. So the graph of the function, right, represent odd function. Okay, does that match your expectation? I hope so. That's the solution.